Hello everyone and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best engineering college and the best college in the entire country. It has a variety of courses to choose from BTech, BBA, BCA, and they're soon starting up with architecture, MBA, and law. This is one of the finest college in terms of education. It focuses both on the quality of students also and also on the quality of teachers also. You will find very reputed faculty teaching out the subjects with very keen desires or a passion for teaching found in them. The infrastructure is the best. If you look at the hostel facilities, it is very good. The environment, or I would say the surrounding environment, is so lush green and away from the hustle and bustle noise of the city, yet very easily approachable from there. This is one of the finest college that you can take admissions into. Let's start with the video. The subject we shall be taking in here is Mathematical Foundations of Computer Science, BCA 108. This is a BCA second semester subject. The topic is Adjacent and Incidence Matrix. I, Shalini from CSC department, shall be taking you forward. Adjacent and Incidence Matrix. The graph data structure is represented using following representations: adjacency matrix, incidence matrix, and adjacency list. Adjacency matrix. In this representation, the graph is represented using a matrix of size of total number of vertices by a total number of vertices, like the vertex cross vertex, right? That means a graph with 4 vertex is represented using a matrix of size 4 cross 4, 4 rows and 4 columns, and both rows and column represent vertex. So this matrix is filled with either 1 or you fill it with 0. So 1 represent if there is an edge from row to column, and 0 if there is no edge from row to column, right? So you will write ABCD if you have 4 and ABCD on the column also, and we can look it with an example. See, this is a graph and this is an undirected graph. So you write all the vertex on the row subscript and on the column subscript: A, B, C, D, E, A, B, C, D, E. Now what you do, now you actually look if you have an array or you have a connection from between the two nodes. So from A to A I do not have, and this is an undirected graph. So if I'm going from A to D, it means there is an edge from D to A also. So there's no connection from A to A. From A to B there is a connection. From A to C, yes, so we write 1. From A to D there is 1, and from A to E we cannot go, so we put on a 0. Now we look at B as the origin vertex, and from B we starting seeing that what kind of edges we have. So from B to A, yes, there is an edge, we put 1 over there. From B to B there is no edge, so 0. From B to C there is no edge, so 0. From B to D, yes, we have an edge, and that is 1. And from B to E, yes, we have an edge, so it is 1. Similarly, we do it for all the other subsequent vertex. Now this is a case of undirected graph. What if we have a directed graph? See, A, B, C, D, E and A, B, C, D. Now if I start from A to A, there is no loop, so I put a 0. From A to B, yes, there is 1. From A to D, no, I cannot. From A to C, yes, there is. From A to D, I cannot go, so it is 0. And from A to E, it is 0, right? So if I look from B to A, I cannot go, so I put in 0. Although there is an edge, but it is not from B to A, it is from A to B. They have a connection, but not from B to A, right? From B to B, no. From B to C, no. From B to D, yes. So we have from B to D we have, so B to D I put 1 and B to E I put 1. So this is how you do in a directed graph: 0 and 1. Please remember. Next we come to incidence matrix. See, this will be represented by the total number of vertex and the total number of edges, and you multiply the two. See, if you have graph with 4 vertex and 6 edges, so the matrix size would be 4 cross 6. So 4 would be the rows and 6 would be the edges that would be there. So in this matrix, rows represent vertex and columns represent edges, and this matrix it filled with 0, 1 or -1, right? So you put vertex on the row and you put edges on the on the column part. So 0 represent that row edge is not connected to column vertex. So if your row is not connected to column, you put a 0, and 1 represent that row edge is connected to outgoing edge, right? So if it is an outgoing edge, then you put 1 and minus 1 if there is an incoming edge to the column vertex, right? So we see how it is done with an helpful example. See, I put A, B, C, D, E on the row, and I put E to A, E8 as the edges one by one. So from A, yes, I have an in and it is outgoing from A. So I put 1. From E to E2, yes, so I put 1. From E to E3, minus 1. So minus 1 shows that this is incoming. So nothing is going out from A, but it is incoming to via E1 is incoming to A. And E2, E4, 0, E5, 0, E6, E7, E8, all 0. Now I start with B. So B to E1, it is minus 1. Why? Because E1 is incoming to B, right? B to E2 is 0. B to E3 is, so B to E3 is again 0. B to E4 is, B to E4 is, where's my, yeah, this is 1. So I put 1. B to E5. So B to E5 is again 0. There's no connection whatsoever. B to E6 shall be 1 and B to E7 shall be 0 and B to E8 is again be 0. So I just put this entire thing into this graph, right? Okay, now this is not in your syllabus, but still I would be discussing because there are three representations of graph: the adjacency matrix, the incidence matrix, and the adjacency list. See what you do in here. So you, if I put a, I put all the vertex onto one by one down the other. A, B, C, D, E I put. Then I see for each representation, vertex of a graph contain list of its adjacent vertex. Example, for the directed graph, I'll represent it with the help of ink list. So A to B, there's one row, and from A to C, there's one. So A to B, I write on the adjacent side, and B, C also I write. From A, I can go to B also, and C also. Now from B, wherein I can go D and E. So I put D and E on the same level from B. Similarly, I do it for all the vertex. In the last, I put a cross. Why? Because it's a list, so it represents null. From E, I cannot go anywhere, so I just put a null. Okay, and then you help it, you can represent it with a sort of an array also. So what you do, see, your 0 subscript is representing your A vertex, that is your B and C here. So one will have BC, 2 will have DE. See, look, we have DE. And sorry, 0 will have BC, so this 0 will have BC, 1 will have DE, 2 will have D, and 3 will have ADE, and 4 shall be null. So this is how the array representation would look like, right? So we are done, and it's very simple topic. I hope you understood it. So there's following question that goes by, that what are the ways to represent a graph, right? What is adjacency matrix, what is incidence matrix, and what is adjacency list, right? So I hope it is clear. Take care of yourselves. Bye.